Yeah, I hope the screen is visible for you. Yes.
Screen not yet visible, but we can see you. Yes, yes, screen is visible.
Okay, fine. So let's get started. Okay. So, like I said, what we'll do is we will discuss this topic, building energy analysis tools, in two parts. So, in the first session, in the morning session now, what we'll do is we'll just try to understand an overview of what are building energy simulation softwares and where do we look for tools and which are open source tools, which are commercial tools, and so on and so forth. And this will be the first initial part. We'll just try to see which tool we will have access and which tools can be used free of cost. The second most important thing is, see, when we run a model or when we simulate buildings, when we analyze buildings for climate and so on and so forth, one of the primary requirement is the data, right? Weather data should be there. So where do we look for weather data? And how weather data is formed, we need to have some kind of understanding on this as well. Then probably we'll have a better understanding or better hands on how do we process this information further. So we will spend some time on how do we access weather files, where do we look for weather files, and also a little bit on how these weather files are formed. Okay, for example, let's say when we do analysis, let's say many of you must have done basic analysis like shading, solar exposure analysis, right? So this phase is getting exposed, or the amount of shaded region that we get is XYZ. All that we will try to get. But all these things are based on the latitude information, okay, and that helps in understanding how this shadows are formed or how solar exposure is can be quantified on facades. But if we want to run simulation, or if you want to understand how the building is performing in terms of energy, in terms of what is the kind of lighting load needed, all that, we need little more information than just where is the sun and how much is the sun angle and what will be the shadow pattern that we will get. So we need more information more weather information or the climate information, so that we can give that as an input and then process it further. So in that way, climate data is very, very essential for us to process or for us to take it further, okay, in terms of climate analysis. Then what we will do is we will explore very simple tools available in the open source platform, where we can see how do we understand this 2D sun path, 3D sun path, and what is CIE, how does it impact on building, and we'll also try to understand shading, little bit of shading, and also we'll see shading mass. How do we what is shading mass and how do we understand shading mass for a building, so that we have some understanding on how do we block the sun and when do we block the sun, or when do we let in the sun, and so on and so forth. Also, we will do one small analysis on daylight. Okay, so for example, let's say if you have a very basic model for a specific location, how do we do daylight analysis? Okay, I'll just introduce the tool. It's very simple. You need not have expertise skill for running this tool. However, we need to have good understanding on the science, the terminologies used for analysis of daylight and how do we process the data and so on and so forth. Otherwise, this as such the tool is simple. Okay, I'll explain you in the process. And I'll also show you one tool where we can do the whole building simulation analysis. Okay, so here we are just seeing how do we analyze the daylight. Here we will see, let's say if you want to assess the entire building for its energy performance, how do we do that? Okay, and I'll also give you some brief information on what are the different tools available at building level that you can look for, that are commonly used in commercials, and also some of them are open source. Okay, so this is what we will try to do in the morning. I hope we will be able to finish it on time within 2 hours of time. In the afternoon session, what I thought is we will probably develop some understanding on, or you already have information or understanding on what is climate and how do we understand the components of climate, so on and so forth. We will see from urban perspective how do we understand this component, what are urban climate components, and what happens in the urban situation. At building level, we do a lot of things. Okay, so probably if knowingly or unknowingly, what do? We just put a diagram like this, and then this indicating this is the sun path, and this is going to be the wind direction. Okay, but can we do the same thing for an urban layout and say this is the sun and this is the wind direction? The answer is yes, and the answer is no also. We will see why and how, what is the change of understanding. Yes. Yes.
Can you hear me?
Yes.
Oh, Professor Navara, can you hear me? We've got a power cut here.
Okay. Yeah. So what I was saying is we do have some kind of understanding at the building level. We will also see how do we take that understanding to the urban scale and see what kind of fundamentals that we should know so that we can apply that in an urban context. So in that way, we will try to see what are the fundamentals of things that we should have when we proceed with urban scale interventions, and we'll see what are the different scales in which this can be done. This again, you will see people talk about regional analysis or regional interventions. People talk about district level intervention, city level intervention, or maybe cluster or urban block level or neighborhood scale. Okay, so there's a different scale in which climate studies can be done and the understanding can be applied. Okay, so we will try to see that as well, and also we will try to see some understanding that we need to have when we discuss about urban level issues, and what are the different tools available. Again, like this the intention of this talk itself. Where do we look for the tools, and how what are the ways in it you can use it for analyzing buildings and urban clusters and so on and so forth. And in the end, I'll try to show you some case studies that we have done, not at the building level. I'll not show some work done at building level because that is known to everyone. I'll try to show some work which is done at a neighborhood scale and above. How this, whatever we are trying to discuss here, can be applied in the form of research or in the form of studio work, and develop some understanding, so on and so forth. Okay, so that's the entire idea that I have for the day. Let's see how we proceed. Okay, so the first thing is building energy simulation software. Okay, so my talk is primarily on tools because what to say, I like to push students to use these tools for support in support of their decision. Okay, so these are kind of a tool that will help in defending our assumptions. Okay, so suppose if we say we will get enough daylight in a particular, let's say in this particular unit, and I have a opening which is of let's say 30% opening in this facade, and I say that okay, I assume that this 30% opening will be enough to get it required daylight in that particular room. Okay, this is an assumption, and this assumption may be true or may not be true, so that needs to be checked. How do we check that? We can use the simple tools available to check really whether 30% is sufficient, or we need to go 35 or 40% opening, so on and so forth. So this is one example. So for that matter, we can use tools to defend or to make our point explicit using these decision support tools. Okay, so there are n number of tools available in this case. Okay, so if you look for papers, if you look at the literatures available, I'll also show you some of the sources where hundreds of tools are available. Okay, so which tool we should use and which tool is acceptable in the market, whether if we use an analysis using a particular tool, whether that particular analysis will be accepted or not, that's another question, right? So we should know which tool to be used also. Okay, so where do we look for this particular let's say an archive where we can have a list of tools? I'll show you in a while. Where do we look for? One of the reason why people don't use these kind of tool is the complexity involved in it. Okay, so when we talk about the climate or modeling buildings for climate analysis, one of the issue is modeling itself. Modeling itself is a challenge. Nowadays, I think it is relatively easier because we often use CAD, Revit, or Rhino, and so on and so forth. SketchUp, of course, for modeling buildings. Now, can we use the same model that we do in these platforms for energy simulation? Some of the platform, there is an acceptability of these models, which we try to model in SketchUp and Revit and so on and so forth, which you can directly take it to energy models and do the assessment. Some of the tool does not have that features. Okay, what we need to do is we need to do a different model for that. Also, the kind of model that we do for architectural rendering and so on and so forth, the kind of detailing required is different from the kind of detailing required for energy models or performance assessment models. Okay, we will also discuss about this later as we proceed further. Okay, so if you, in fact, there is a paper on this. What are the tools available in the market that we can use for building building simulations? Okay, there's a paper by name, a review of web-based building simulation analysis applications, primarily available for architects, modelers, and so on and so forth, which can be which we can look for. Okay, actually there are the entire tools can be divided in different ways. For example, which is openly available, which requires less input data, which gives more. Actually, we can say that let's say if there are 4 categories. One is of course open source, commercial. This is what we know. But in the let's say from academic and research perspective, we need to know there's something called hidden models. For example, in a simplified modeling tools, okay, what the kind of data input that we give is relatively simple, okay, and we do not have control on the background model in which the energy simulations are done. So maybe sometimes it is okay. Let's say for many a times, let's say I would say 8 out of 10 times this is okay, because not all architects are trained to check the models that is inbuilt in the tool for running simulations. But for research and further analysis or further exploration, for example, if you are doing specialized course on energy modeling, this simplified model is not enough. We need a detailed model where we can have a control on the model itself. Can we modify the model and then use it for refining the results? So softwares or tools can also be divided in accordingly as well. And there is a list available, a comprehensive list could be found in building energy simulation tool directory. What is this building energy simulation tool directory? I'll just show you once and then probably will tell you what is it and why it is relevant also. I think I already opened it. There is a platform called, you can see here, the directory of building energy simulation tool. Basically, let me tell you, see, if we have to look for information, where do we look for information? We look into books, and we look into articles and so on and so forth, and we look into the institutions where this kind of works are done.
Faiz, sorry to interrupt. Are you projecting something? This is Priya ma'am.
Yes, ma'am. You're not able.
Are you projecting something, sharing something on your screen?
Yes.
No, because we are not able to see it, Faiz.
Okay. PowerPoint was not visible?
No. So when you were talking about the classification and all that, there is
Okay.
try sharing your screen.
Okay. Yeah. Okay. That's okay.
Yes. Now we can see it. Go on, Faiz. Thank you.
Fine. Sorry. Yeah, I think that's I did not share the screen, I guess. Fine. No issues. So what I was saying is, so if we are looking for information, we look for books, articles, and institutions where this kind of research is done. So there is an association called IBPSA, okay, International Building Performance Simulation Association. Okay, so that association is primarily it has a different chapters across the country and across the world, and they do state-of-the-art research work in building performance simulation related stuff. So this is one of the platform where they have a list of softwares, a list of tools that we can actually look for. For example, let's say I'll just put it here. You can also explore in your places. The list of softwares are already classified based on different categories. For example, let's say if you're looking for whole building energy simulation tool. So if I click here, so there are 71 such tools available for whole building simulation alone. Okay, so for example, maybe those who have heard of whole building simulations and how do we do energy assessment, you must have come across Design Builder. Design Builder is one of the tools that is commonly used, softwares and so on and so forth. So there are n number of tools available. Okay, you can see just 71 such tools are available only for whole building simulations itself. So like that, there are n number. Let's say if you are interested only in looking for daylight. So again, for daylight, there are some specific 23 tools are available which we can look for, and some of it is open source, some of it is commercial. Okay, So all the tools are acceptable, all the results that you will generate out of this, okay, are acceptable if you let's say if you are publishing it or if you are taking it into for example, let's say if you are submitting some documents for compliance, let's say daylight compliance, if you are submitting some documents for Griha, lead, so on and so forth, we have to submit a supporting document that we are satisfying certain criteria. So all these tools are the results generated using these tools are acceptable. Okay, so this is one thing you can look for, and there are other things, for example, airflow simulation, so on and so forth, and or if somebody is interested only in understanding the U values and so on and so forth, all that specific tools are there that you can explore. Okay, then that's the first part. Okay, so we should know where do we look for tools, okay, which are commercial tools and which are open source tools, okay, that we can look for. One. Now the second thing is, okay, we have a tool, we have identified one X tool, and we need to do model and generate some analysis for this. In order to do this, we need input data. Okay, so that input data primarily is a weather data, so that we understand how this building interacts with the environment. That's what we are interested in. How is it interacting with the environment, and how do we analyze that? So the weather data is one of the input data that we should have access to, and that will give you a lot of information on how the building will perform and so on and so forth. Okay, so that's why the building simulation tools are powerful in this way, because we'll be able to virtually model and test. Okay, every time it's not possible for us to build and test, right? Maybe for lab exercise, maybe we can do a scaled model and test whether the building is performing well or not. But if you have to do that for a large scale or even for these smaller buildings, but we need, if you are testing some openings, if you are testing certain envelope designs, so on and so forth, we should know, we should have correct model. Of course, probably we'll be able to do this building model very accurately, but can we accurately model environment? Okay, that's the question. That's another part that needs to be understood. Okay, so building model, of course we can do. So what we are trying to do is, we need the second input, that is environment, which is primarily nothing but the weather data associated with that particular location. And weather data is actually, there are two ways in which this can be read. Okay, one is we have very fine weather data, which is hourly data. So every hour, for example, 24/7, we collect information in terms of temperature, humidity, the wind velocity, and so on and so forth, and that is collected over a period of time, and data is produced. Okay, so that can be given as an input for building simulation. Some of this information is freely available. Again, we should know where we should look for this kind of data, so that we can use it for our purpose. Okay, so the second question is, again, whether this data that we are going to use is acceptable or not. First thing we have seen, the kind of tool that we use, whether it is acceptable in the commercial sector or not, or in the research forum also, whether those tools are acceptable or not. That's the first question. Second question now is whether the kind of data that we use, okay, for simulation is acceptable or not. That's the second thing that we should have an answer. And I have put one paper here. Maybe I'll share the presentations later on. You can look for the paper that's mentioned here. How this weather data is generated, okay, and what are its deficiencies, and where do we go wrong with this model. Otherwise, how acceptable, what is the acceptability of this data that we have in hand. Okay, so you can look for, if you are interested to know more about it, you can look for this particular paper that I put here. Typically, it's called, I think many of you should know, otherwise also fine, no issues. There is a term called typical meteorological year data that is used as an input for these simulations. What is a typical meteorological year data? Actually, I don't think we should be discussing on what is weather and what is climate and so on and so forth. I believe we all understand that term. When we say weather data, okay, it is not a short term data, okay, it's a long term data based on which a typical meteorological year data is created. For example, let us say we want a data for 2022, okay. So in a weather file that we are trying to use that as an input, what it does is it is not going to be a typical 2022 data as such. It is going to be a typical 22 data. What do you mean by that? We'll go back to last 10 years of data set, let's say from 2012 to 2022. A typical month is taken from each of the year that is there from 2022 to 2012 to 2022. 10 years data, 10 years we go back, and then typical year data, monthly data is taken. For example, let us say if you are downloading a data which says TMV and it is 2018. So if you go and look for metadata, further informations about this, you will find that the January data of 2018 is taken from 2006. Okay, I'm just telling you for an example, as an example. Okay, so February data is taken from 2017, March data is taken from 2011, so on and so forth. Okay, so any issues? Sorry. Shall we continue? Any issues?
No, let's continue. Let's continue.
Okay, fine. So I was trying to say that typical meteorological weather data means we have some ways in which this data is built in. Okay, so where do we look for? Okay, again we should know where should we get this data. Okay, so let me explain you before we go into the site where we can get the data. I'll explain you little bit on how this data is also formed. Okay, for example, let us say should we all every time depend on the meteorological department for the climate data, or can we create our own data? We can create our own data provided we have a local weather station. Okay, we can have a local weather station installed, and then you can collect the information for every day. Okay, so once you install the local weather station, we'll be able to record temperature, humidity, air velocity, and so on and so forth, other solar exposure, and so on and so forth. All weather related information can be acquired over a period of time. In fact, in SPA Vijayawada, we have installed one local weather station in, I think, if I'm not wrong, 2017 or 2018 we have installed. We need, it's just 2 years data that we have. Probably we need little more data so that we can say that we have substantial amount of data for using it as a primary input for data analysis. Okay, so one source of information, we can in fact generate information. We can collect primary through primary sources as well. For example, let us say many times what happens is we use typical weather files for building energy assessment, so on and so forth. What happens is, in addition to that, we also do some physical measurement. We take instruments and then we try to measure temperature, humidity, air velocity, and solar exposure, insolation, whatever information that we are trying to collect. We take instruments and then we also take some primary readings as well. Why do we do that? It is just to validate whether the simulations are right or not. For example, let us say if we plot, I'll just swap screen. So if we just swap, if we just plot, let's say, weather file, let's say weather data, and let us assume this is temperature, okay, as per the weather file, and we have collected some information from the primary sources, and let's say we have collected for a week, okay, and it is coming around, let us say it is somewhere here, okay. We don't have information for other time period, we just have information only for this. We don't have information for here, let us assume that. So what do? Is we use this primary data to validate the results. What is the error between the simulated weather file data and the actual data? Okay, so that in that way we can use we adapt the primary data set as well. Okay, that's first thing. The second thing is we do have weather stations. Okay, wherever airport is there, for all the cities they have weather file for that particular city. For example, Chennai, Meenambakkam, so on and so forth. All cities wherever you have the airport, we have a weather station there. Okay, that's the requirement, and we can also access that particular data. Okay, now if you are in a place where you don't have a weather file, what do we do? Again, there is a tool called Metronome. Okay, Metronome is something where a tool which helps in acquiring the weather file for a specific location. Okay, how does it do? For example, let us say we have a city. Let's say we have 4-5 cities. Let us assume, and our study is here. And we have weather station for this, and we have weather station for this, we have weather station for this, and we don't have a specific weather station for this. Okay, for example, let's say yesterday we had a typical similar issues. We are trying to analyze a site in closer to Chennai, I forgot the name, Arakonam. Chengalpet, Arakonam, yes. Yeah. So we don't have weather file for Chengalpet or Arakonam. So what do we do in that case? We can go to, we have a tool again, this is something called, it's called Metronome. What it does is it interpolates the weather file of closest 5 weather stations, and then we get a interpolated data. Okay, interpolation, interpolated data for particular site. We can also use that. That is also acceptable in the research and in the commercial aspect as well. Okay, that's the second part. Third part is, of course, we have a lot of open source data available for major cities in India and across the world that we can look for. There are 2 ways in which you can look for. This one is called Energy Plus database, and the second one is called Climate One building. I'll just show you the site itself so that you can also have a look at it. So the first one is Energy Plus. Maybe I'll both the things I'll just put it in the chat box. You can also parallelly explore. Energy Plus by itself is a software. Okay, this is kind of a model that works in almost 8 out of 10 energy simulation softwares. Okay, so this is a free software again for whole building simulation, but we are not discussing that. We are just trying to look at the weather file. So you go to weather, click on the weathers, and if you look here, and we have Asia, you can click here, otherwise go to India, and we have a lot of information on this based on specific city. For example, for Chennai we have 2 data set, and EPW file is one of the file format that is needed for running whole building simulation. Okay, so also I request all of you to you can download, maybe if you are in from some part of the city, and if you can find your city or closest to your city, you can download the data and keep it. Maybe we are trying to do some exercise as well, and that time it will be useful. This is one source. The other source is you can look for climate1.building. This has got little more information as well. You can go to Asia and India, and for different state. Okay, we are from Tamil Nadu. Let's see. Yeah, we have for different cities. Some of the cities we have some information here. Okay, so you can download and keep it. Maybe I'll just download one, and then we can use it for further studies. Okay, that's the second part. So first is the tool, the second one is the weather file, input data. If you don't have weather files, we have a tool for generating specific weather file based on interpolation. Okay, that's one thing that you should keep in mind. Okay, now the actual thing. We have the information with us now, so we have some tools with us, and we also have some data with us. What are the different ways, or what are the different things that we should have an understanding on before we actually proceed with designing our buildings, or specifically if you are interested in climate responsive designs, so on and so forth? How do you apply the understanding of climate science in design of building? I believe that these are the basic things that we should have an understanding on. Okay, so and most of the tools that I am trying to show in this session is all web based, free of cost, web based, and you can try on your own. I'll show you some demo on what information that we need to take for design purpose. Okay, and later you can spend time on, and probably you must have already used it also, or maybe you may not have looked at the tool from let's say the actual climate perspective itself. Okay, so one of the tool is of course Climate Consultant, you must have explored, and there are 4 or 5 tools that I have listed here, all taken from Andrew Marsh web-based tool. Okay, and many of you must have already used it. Otherwise also, this is all free tools available that we can use. We'll try to check all these today, and then we'll see what we can do using these tools. Just to briefly give an idea on why this is relevant, I think you must have heard of a tool called Ecotec, which is no longer available in the market, right? Ecotec, now it is actually inbuilt in Revit. Whatever energy simulation, Yeah, sorry, any issue?
Sorry, someone locked in. Sorry for that.
Okay, shall I continue?
Yeah, you can continue.
Yeah.
Thank you. Yeah.
So, I was saying Ecotec is now inbuilt in Revit, and standalone software is no longer available now. So it is actually developed by an architect, and he has developed many such web-based tools which we'll see today, which we can use for have an understanding on how do we use this climate data. Okay, so that we are very sure of what are we talking and how we can translate what we understand from the climate into the design applications. Okay, before we go into the tools, I would like to highlight few things on how do we approach building simulation or building energy assessment itself. So we all know what are the different components that makes up a building, and energy simulation softwares are in line with these components. For example, let us say we have something called apertures or opening. Okay, so there are specific tools designed only for analyzing glazing, specifically designed for how do we quantify heat coming in through the materials and so on and so forth. Okay, so this is one way of looking at the tool. Okay, in terms of aperture, what happens, what is the physics behind the environment, the external environment and the building, and what kind of input is needed so that we can actually model the building as such. The second component is of course it's called observer, or where we transfer some of the heat wherever the building touches with the external environment. Okay, what happens, what is the kind of heat exchange takes place between those surfaces. Okay, we need to have some kind of understanding on that so that it can be modeled in a better way. Third component is on the wall component, which many of us we use a word called thermal mass, or we use a word called time lag, so on and so forth. Okay, what is the composition of the materials? Okay, how do we arrive at R value, U value, so that it satisfies the requirement of the building as such. Okay, and the third and the fourth component is on what happens internally. Okay, how heat. In fact, you must have studied this in the introduction to building sciences as well, where we talk about conduction, convection, radiation, right? So, okay, we have some component on physical component. Okay, we have different ways in which it can be understood. How do we understand this convection aspect? How do we know that, okay, what happens in an internal environment? Okay, so again, for this specific question, we have specific tools. We can use very simple tools for analyzing this aspect. And of course, for shading, we have probably this is one of the most commonly used tools for analyzing the buildings in terms of shading, how much shading that we get, how much light we get, and so on and so forth. So depending on the building physics component, we can also look for the tools. Okay, that's one thing, as simple as that. Okay, so if you are not interested, see, it's not necessary that all the architects should sit and do the whole building simulation, not required. In fact, many times I also say that this so-called rating system is one kind of business. Okay, it's one kind of business. So we many times we get carried away by these simulations and so on and so forth. Otherwise, just from the science perspective, we should know, as an architect, we should know how valid our arguments are, how do we convey our ideas, okay, whether it is scientific or not. So in order to do that, we need to know certain tools. Okay, so it can be whole building simulation or it can be part. Okay, if you are just trying to understand what happens to the shading component, what happens to one thermal mass, what kind of thermal mass that we should have in hand. Okay, so with this perspective, we can look for specific simplified tools to support the arguments. Okay, so what I do now is to proceed further, we should know certain things called how do we model it. Okay, in the beginning itself, I told you we do model in the architectural terms. We do model like this, right? In fact, better than this. We assign materials, we assign furnitures, we bring in life into the renders, right? But for energy simulation or energy assessment, we don't need this level of detailing. Okay, from the academic or from the research perspective, this is not required actually. Okay, there are simplified ways in which models can be made. Okay, it's called actually archetype, and it's one of the commonly used tool or approach, rather not tool, as an approach for energy simulation. Okay, what are this archetype? And also you can see here LODs is called level of detailing. Let's say if we are interested in analyzing the a neighborhood, okay, and that neighborhood has got, let's say, 1,000 buildings. Can we sit and simulate, model all the buildings like this, and then arrive at what is the performance of this building, how individual buildings are performing, and so on and so forth? We can do, it's not impossible, we can do, but it may take years to collect the data, to model it as realistic as possible. So from literature, what we can understand is this issue of modeling has been simplified. We don't need this much detail if you are going for a large scale modeling. Okay, as when you go further, let's say if you are interested in modeling only one building, of course that time you can adapt this strategy where you can try to model as realistic as possible. Otherwise, even abstract models like LOD2, LOD3 is sufficient, or in fact even LOD1 is also sufficient. What is LOD1? Is, you can see from the image itself, it's a very three-dimensional volumetric model. It does not give further information beyond this. Okay, we just assume maybe when we see a tool, we'll see that what kind of data input is given, assuming let's say this is going to be residential. How do we assume that what is the wall made of, what is the roof made of, what is the volume that is there, and what kind of openings are there? Okay, very simple 5 input. Maybe when we discuss about this MIT tool, MIT whole building simulation, that time we will see how whether we are modeling this, or we are modeling this, or we are modeling this. Okay, so now the question is, in the beginning I said we all are familiar with architectural models. We do architectural renderings. Can we use that model for energy simulation? I said the answer is yes, and the answer is no also. The answer is yes, provided if it is if the model is acceptable in the energy simulation. For example, let's say many a times even SketchUp models, if you take it to 3ds Max or for any other, even for Lumion, you will have issues in the model. Okay, some face may not be visible, some face will be dark, and you will not able to see one face. Okay, there will be some issue with the model. To avoid that issue of model, okay, and to bring in more accuracy in the results, it is always advisable to do model in the same platform in which you do the simulation itself. Okay, so for example, let's say if you are using Revit as a base for simulation, you can use the same model. Okay, you can use the same building model tool for energy simulations as well. For example, if you are using Energy Builder as a simulation tool, it is recommended that you use Energy Builder itself for modeling as well. Okay, why? For to avoid the errors which we will not be able to understand also sometimes. Okay, we will not be able to figure out where are the errors and so on and so forth. And also many a times we don't need lot of detailings that we try to do here in the architectural model. That's another thing. So for example, let us say it may not be able to let's say you have some undulations in the roof. Okay, all those things are not possible to model in energy tools. Okay, it will assume that what is the material property and what is the thickness. Okay, so we don't have to have that accurate detail for simulations. Okay, this is one thing that we should keep in mind as far as models are concerned, and we will discuss this along with the urban studies as well. How do we use this approach in modeling urban level issues as well? Now we'll go back here and we'll just try to see some tools which I would recommend everyone since you are starting the course. Before you proceed with your design, you should have fair understanding on different tools. I recommend few tools that you should explore before you actually jump into design or exploring it. So one tool is, of course, 2D weather data. Okay, you can launch the tool. I think should I put it here? Maybe.
Yes, Dr. Chris?
Yes.
Oh, you posted it here. Okay. The students have access to it.
Yeah. Okay. So once you yes. Somebody is trying to say something. No. Okay. Fine. So what I have done is I'm just trying to use this 2D view. Okay. This is how do we read weather data. We'll come back to other tools in a while. First, let us see how do we read the data. Okay. So one of the difficulty in the subject on climate is the data itself, right? So we hardly understand things, and we have difficulty in taking which parameters to be used. So I think we have downloaded one in weather file. I'll just see that. Okay, this is what we are looking for, EPW file format for reading the data set. So I go here, you can load the weather file, you can click here and load the weather file. Okay, so once you have loaded, you can see on your left there are a lot of information that is there. Maybe we'll just uncheck and then we'll come back one by one, which is most relevant for us. Okay, so the weather file, latitude, longitude information, now you can see whether what is that your which city you are looking at it. And of course, one of the data set that we need to know is on the dry bulb temperature. Why I recommend this is, see, many a times what happens is we just look at the data very from far away, okay, and we say that okay, May has got highest temperature, June has got relatively lower temperature, that's all. But if you dwell with the data for some time, you will know how the data reacts, what you can do more. Okay, for example, let us say this tool is very interesting because you can manipulate and see what happens every day. Okay, this is this is daily high, daily low, daily high, daily low, so on and so forth. Okay, if you zoom in and check how this profile or what is the variation in the data set. Of one data that we use, of course, is on the dry bulb temperature. Okay, the other information that we'll be using is, of course, on the relative humidity. What is the humidity level, and how do we relate it with the data, and also we will be using these information for example, let us say if you are using a psychometric chart, okay, and if you want to derive certain observations based on this climate data, on which for which part of the month we need some kind of passive strategies, for which part of the month we need some additional strategies in addition to passive strategies. Okay, so all those things are possible with if we have a closer understanding on what happens monthly, what happens on the daily average, and so on and so forth. Okay, this is one thing. Okay, I would highly recommend that you should definitely check the data by yourself, just to feel on how the data is plotted, what happens, and so on and so forth. Okay, this is one tool just for reading the data, 2D data. Same thing, I would also recommend you to do a reading of data using 3D platform as well. This is slightly interesting than 2D data set. I'll just load the same weather file here. Okay, so this is the weather file for 365 days, 24/7. Okay, and in here this is Jan to December, and we have information on 0 to 24 hours. So let's say, for example, you are looking for specific months. Let's say this is month of July. Okay, and we are looking for a temperature profile. Okay, this is horizontally. You can do longitudinal data set as well. Okay, longitudinally on that particular day, what happens across the year. Okay, and let's say this is for the month of July, and so on and so forth, whatever date or month you are interested in, and what happens in longitudinally as well. Okay, fine. What do we learn from this? Okay, what kind of what do you say, what is the additional thing that we can draw from this particular tool? My observation is, many times, this is just for making it interesting. Okay, many times what happens is we just take from Google, we just try to plot. Okay, this is temperature, humidity, and we draw one diagram and says this is windrose diagram, and this is predominant wind direction. Okay, and we actually don't get to see the data itself. Okay, what happens if you closer look at the data is not possible if you do this kind of approach. Okay, and that's why we are not able to relate the data with our observations. Many a times that's what happens, because we just get the processed data saying the maximum temperature can be observed in so and so period, and humidity at that is 80%, 75%, 90%, so on and so forth, and we just observe it. Okay, we just take it, and then we try to implement that. But if you have to develop, or if we have to develop understanding, better understanding on this, what we need to do is we should explore with the data, we should spend time with the data, so that we have a better understanding on how it works. Okay, what we can do. Okay, so this is only to do with the reading of data, nothing more than that. Okay, so you maybe when you're you at your leisure time, what you can do is you can explore this, how this particular tool can be just for reading the data, how you can read the data in a different way. Okay, now let's go back. Yes, sorry, yes.
Just asking the students to try this simulation hands-on. There are 5 minutes for them to try it out.
Okay, yeah, they can, yeah, no issues, they can do that, yeah.
We have asked them to bring their laptops and the second is there. So just to see how the data correlates and they personally try it out, they can connect with you for it. Just for 5 minutes, we'll ask them to.
Fine, yeah, they can do that, yeah. Yeah,
Just 5
no issues, yeah, they can do that. Yeah, maybe I can show you more insight on what kind of information that we should look for. For example, let us say if you go here, we have different parameters. All these parameters probably you must have read this in the climatology subject. Okay, so there will be discussion on lux levels, what per meter square. Okay, let's say we are looking at dry bulb temperature, or maybe let's say diffused radiation. Okay. Also, you can look for certain specific things: summer solstice, winter solstice, equinox. Okay, already by default there is a tab where you can check what happens in the summer solstice, winter, and other important days as well. Okay, and we do have control on setting temperatures as well. You can do scaling of these diagrams. This is only reading the data, okay, nothing else we are trying to extract from here, because many times what happens is we don't look at the data closely. That's one of the reason that we don't get attached to it, or we don't not to say attached to it, we don't get to explore further, as if you have to say it. Again, useful dates are there: summer solstice, winter solstice, and so on and so forth, that you can check. Yeah, and 2D also there are similar stuffs are there. Yeah, one thing I did not tell you that you can do is, in fact, you can export it and use it. Instead of downloading the information from Google, you can have your own data set created and you can use that. Okay, so of course, depending on specific study what you are trying to do, you can plot it, you can do whatever you want to do, and it's all your own data now. Okay, you can use it as you wish. Okay, I think this you can explore. I'll introduce you 2-3 tools, then probably you can explore further. Okay, this is about reading the data only. Now let's go into little more things that is actually that we'll use it in our design. Okay, one is 2D sun path. This is again a complex, I would say, not complex. If you have, we have used this, okay, I think in the climatology subject, we have been taught what is sun path and what are solar, the what is it called, altitude angle, the azimuth angle, and so on and so forth. Okay, but still, for many, even for myself, I had some difficulty in understanding this. Okay, how do we plot it? Okay, I know, okay, what is azimuth angle, what is sun angle is fine, but how do we plot it, and how do we do it for a specific site? What happens in the if we superimpose our site? Okay, that's something that I think requires we have to spend some time with the tool or with the method itself for understanding this. So what I'm going to do is I'm going to use the same thing again. I'll just go to, we can't load the weather file here, we can go to site. No, we can't import the weather file, we can just go to site. I'm just going to press my location.
Hello?
Yes.
Sir, I request you to slow down a bit. I am not able to follow you.
Okay.
Can you please repeat the previous step?
Yes. 1 second. Okay. I'll just relaunch this. I'll just close all this. Okay. This is okay. In a simple way, what we are trying to do now is we are just trying to get a sun path diagram for a specific location. Okay, let's say that's the objective of this discussion. How do we get the sun path diagram for a specific location? Okay, and how do we read it? We will do that after some time. But first of all, how do we get it? Okay, that's the first thing. So what I'm going to do is I'll just go here. You can look for location. Okay, go to map and see where you are located. I'm here somewhere. Yeah. I'm just trying to find where are we. It's written Siddhartha something, but that's not the correct one. Yeah, we are here. Okay, I'll just say apply changes, and you can see there's a change in the diagram, sun path diagram. Okay. Okay, if you have not still understood, let us say what are we trying to do is, 1 second, you can see this is June. Okay, this is the June line. Okay, and if the sun moves, okay, this is the maximum, this is the this is for the December month. Okay, this is the what do you say? The area in which we can plot the sun. Okay, for the entire year. Okay, and if it depends on the latitude and longitude. Okay, since this is Vijayawada and we are getting a map like this, maybe what we'll do is we'll just see today. Yeah, we are in Feb 8. Okay, we'll just take the time zone is fine. We are at 12. Okay, we'll skip 12. I'm just taking a screenshot, just not screenshot. Okay, this is for Vijayawada. Let me take some other place. Let's go south. Okay, somewhere in the south. Not much change in the sun path. Okay, I don't know whether it's visible or not. Maybe let's see which is where we can absolutely see difference in the sun path. Let's go to Delhi. Okay, let's take this chart. Let's take somewhere. Okay, so we have some chart with us. Okay, we have some chart. Let's say, for example, this is Vijayawada. We have taken for Delhi. This is somewhere in France, Paris, and somewhere in Australia South. Okay. See, the kind of sun that we see here is like a perpendicular, almost perpendicular, right? So if we have to draw, I think in the next thing, we'll also see 3D sun path as well. If we have to draw this cross section, okay, cross section of this data, it's like this, okay, and we have a city and we have the sun, okay, somewhere in this from here to here, okay, throughout the year. Okay, this is the maximum, in fact more steep, not steep, more perpendicular in fact. If you go further north, okay, you can see this Delhi, for example. What happens? The sun is slightly tilted, right? If you do a cross section, Okay, and this is Vijayawada, Delhi. Let's say this is somewhere in France. It's further stream, okay, somewhere here. That's the amount of sun they get. This is Australia, is opposite, right? We have sun somewhere here. Okay, so we can't have same application. Okay, we can't apply the same understanding that we have for one place to others. Okay, that's why I think when you during your studios or when you do case studies, your faculties must be saying, why are you taking a case study somewhere in Europe which is not applicable for us. When we say that, we say for this particular reason. Okay, for example, let's say the kind of environment that is there, from you can see from the chart, is not same as that you see here in Vijayawada. I can't take some studies specifically. Let's say we are our objective is only on climate. We can't take something from here and then apply it here. Why? Because this is different. This is totally different kind of sun path that they have versus what we have here. Okay, same applies for all the climate, all the places as well. So this is one thing, one aspect of it. Okay, only just by looking at the sun part, we can say how much sun we will get. Okay, and what kind of interventions that we need. Okay, these are actually kind of a perpendicular setup. If you check the data, maybe we'll do that little later if we have time. We get temperatures here as high as 42, 43 degrees Celsius. Okay, so it's very extreme, very hard, and the humidity is also less. Okay, we have a very different climatic setup here. So what I'm trying to say is we need to have an understanding on this level, so that our design are more related to the environment, realistic as possible. Otherwise, what will happen is we assume that the building will perform. It may not perform. Why? Because we have not understood what is the kind of build that we should leave on that particular environment. Okay, this is one thing. Now let's see if we can explore. See, again, I'll tell you from my own perspective. Even what I have seen is this is difficult for many to comprehend. What is this? I have not understood what is a sun path diagram. Fine, no issues. You have a much simpler tool than that. We have something called 3D sun path. Okay, here we have an option for importing the weather file, I believe. Load setting. No, we don't have the option for. No, we can only assign location. Okay, fine, no issues, we can do that. Okay, we are somewhere here. This map is not correct, not much I can say. Okay, we are here actually. Yeah, this is our campus. Okay. Okay, so this is Vijayawada, and you can see the sun path, okay, that we will get throughout the year for the city of Vijayawada. What happens? Okay, we are just still looking at the numbers. Let's say January, okay, January 1st, and time. Let us keep it constant. Let's say we are discussing, or let us do one thing. This is January, okay, you can see sun is not visible. Let's say this is 6 a.m. okay, we are looking at January line, okay, this is January line, okay, 6 a.m. and and this is 7, okay, and you can see the angle of inclination, or the sun angle in which we receive light, or the sun, okay. This is for January line, okay, that's the first line that you see in your sun path diagram, okay. So if we slightly move, let's say if you want to, I'll keep it 12 so that you can follow the red line. Let us follow this red line. Red line in the sense that's the sun, actually theoretical sun, okay. So if we move that to, okay, January, let's say we are somewhere here, January 8, okay, in the sun path you can see which is February line and where is the sun now, okay. And I think you can understand the line or the steepness of sun that we are talking about, okay. This is for February, and if we go further, March, let's say March, okay, you can see the sun, this is you can see the entire line, red line, fine. How what is the movement of sun? And in fact, in the month of, this is April, and in the month of May, June, almost we get a perpendicular sun, right? For example, in the month of May, okay, you can see how it is right on our head, right? So this is, let's say this is only for Vijayawada city, okay, and this is for this particular latitude, no, 16 and 80 longitude, and this is how it works, and this is for different time. You can explore this as simple as possible, and I don't think you need any other sorry, don't change the latitude longitude, that's wrong. Just change only the date, time, so that you understand where is the sun and how, or in this case you are trying to, sorry,
I think there was an interference. Please carry on.
yeah, okay. Okay, so this is how you can just understand what is sun's position when we are talking about for specific latitude, longitude. Okay, now what we'll do is the same thing. What I'm going to do is I'm just going to change the location. The same thing that we did in 2D, it's in fact much better if we can understand that in 3D. Okay, okay, what I'm going to do is I'm just going to change certain settings here. In fact, those things are also there if you want to look at what is summer solstice, winter solstice, equinox. Okay, you can check that as well. And in fact, in this case, we have an option for importing our own buildings as well for doing this analysis. You can go here. I think we need to make a model, or you can make from SketchUp model also. let's say I'll just make some quick model. Okay, let's say this is the model. Save this model, sorry, save this model. Of course, you can bring in own building, okay, whatever detailed building that you want to do it. Load object. Okay, now we have the model and we have the sun path diagram with us. And if you want to specifically modify north, let's say at the moment you can actually operate these things using the numbers, 1 for rotating, 2 for axonometric or isometric view, 3 for plan, okay, and so on and so forth. So at the moment you can see north is pointed up, and if you want to change north orientation, you can modify here. Okay, let's say we have north upside down, or depending on the context, or depending on what you want to do. I'll keep it here. Let's say north is this way. Okay, in fact I was just trying to do one thing. Okay, see, it is easier to understand this in 3D. Okay, now at the moment we are in Vijayawada, and that's how the sun is. Chennai, okay, not much difference. Okay, still slightly, maybe if we keep it here, still we are, Vijayawada is getting slightly inclined solar radiation or the incidence. Okay, Chennai is still perpendicular. As we go further down, we have more perpendicular path. Okay, and if you go further north, of course, as we move further north, you see how the sun angle is and how it will have an impact. Okay, and this can be used, of course, for design. And one of the common thing that we say in the studios is, when we identify case studies, please do not look at case studies from Europe. Okay, don't look at from North America. You can look at the sun angle and other things, kind of interventions that probably they will do for a building we are trying to get some inspiration from, is in Vijayawada or so on and so forth. Okay, so this is one thing you should definitely explore for understanding the sun path, how is it located, and so on and so forth. Okay, so let's go back to the PPT. Okay, so I have said, I think, to download this, we will also discuss this later. So you can visualize the 2D data, weather data, okay, in terms of 2D, 3D. I think my suggestion is, in fact, we spend a lot of time in the studios just to understand hourly data on using these tools, so that we know what are we talking. Okay, so this is one thing. Of course, the sun path also you should explore both 2D and 3D, so that you get to know precisely what are you talking on. Okay, now I have put three more things. Okay, one is called psychometric chart, and the other one is clear sky and shading mask. We will see these things as well. It's not very complex things, that, and just, as I told in the beginning, the theoretical background you have to read. Okay, nobody will teach you again. We assume that you know it. Okay, you have went through this reading in your subjects. Now what are we trying to do is we are just trying to refine the understanding. Okay, how do we use it for design applications? Okay, so if you're not familiar, okay, if you're not familiar with the terms, I think you should quickly recollect the terminologies used for reading sun path, so on and so forth. Now what we will do is we will explore the psychometric chart. I think this is also there in all the subjects, I'm sure, because I have learned in the climatology subject, right? There will be discussion on psychometric chart, and it's one of the difficult thing to understand also. If you don't have right or simplified versions of tools for understanding psychometric chart. So, okay, sorry, I deleted it. There is a tool called psychometric chart here. You can launch that. And I'm sure everybody is aware, everybody has seen psychometric chart, read about it, but it is presumably difficult to understand. Otherwise, but I would say that's not correct. It's actually very easy, but only thing is we need to know how do we plot it or how do we understand it. Okay, let's turn off this. Okay, let's say this is the psychometric, this profile probably you must have seen, and of course this profile also changes. It depends on how do we plot it, but let us assume that we go by conventional shape of psychometric chart. Okay, in that we have something called dry bulb temperature. As what is dry bulb temperature? I think you know it. And something called absolute humidity. Okay, absolute humidity is plotted horizontally. Okay, this is dry bulb temperature is plotted vertically. Absolute humidity or let's say direct absolute humidity is plotted horizontally, and relative humidity that we use is there, you can see in terms of percentage. Wet bulb temperature and other things are probably if required you can use, otherwise we can just stop with wet bulb temperature. Relative humidity, dry bulb temperature, okay, and probably wet bulb temperature for reading it. Okay, now what is psychometric chart? That's the first thing that we should know. See, psychometric chart, using the climate or the weather data in terms of temperature, humidity, it does not consider the air movement as such. Let's say it considers temperature and humidity. Okay, using this and the derivatives of temperature and humidity, we will be able to tell, okay, in a span of let's say 12 months, 1 to 12 months, which month is hot. When we say hot, it's not absolute temperature hot. Okay, we are talking how much heat we feel. Are we comfortable or not? We are trying to define temperature from comfort perspective. Okay, we are saying that if the temperature is more than 27 degrees Celsius, or let's say 27, 30 degrees Celsius, will still be fine. Okay, whereas maybe the outside temperature is 32 or 33 degrees Celsius. Okay, what we are talking here from the psychometric chart is how much we feel, what is the kind of temperature that we feel and we are comfortable with. Okay, so if we know for which period, from let's say from Jan to Jan to December, we will be comfortable. When we say comfortable, again we are relating to temperature. We will be comfortable from Jan to Feb, or from November, December, and so on and so forth. Okay, and for a period from let's say March to June, where the outside temperature is more than 30 degrees Celsius to 40 degrees Celsius. Okay, we are the inside temperature where we will be comfortable or will be around 27-30 degrees Celsius. Okay, so in absolute temperature, probably the outside temperature will be 33, so on and so forth. What we can do, or how do we plot in this the calendar, that okay, these are the areas where the temperature is higher than the comfort zone. How do we map it? Okay, so maybe if you are not clear, maybe I was also little I used too many words to explain that. Let's say we have 12 months, okay, and we are, let's say, comfortable between this is higher, let's say 27, 30 degree. We are comfortable with this temperature. Okay, what now we can easily map in the climate data, okay, which area is having more than 30 degree Celsius in terms of absolute numbers, absolute temperature, air temperature. Okay, we'll be able to map, okay, this, let's say for Chennai, Jan to Feb, probably we are still fine. Okay, from March, let's say the temperature is more than 30, and till June it's going to be in the same range. Okay, from March to June, March, April, May, June, the temperature is going to be more than 30 degrees Celsius. Okay, and it can go up to 40, 42 depending on other locations. Let's say after July the temperature falls down, and let's say theoretically we are fine after June, we are fine between Jan and February. We have an issue between March and June, where absolute temperature goes above 30 degrees Celsius. Now, psychometric chart will help in identifying certain strategies. Let's say if we increase ventilation, if we increase air exchanges, okay, in a room, if we increase cross ventilation in a space, okay, we will feel better. What is cross ventilation? Let's say we have a space, okay, and let's say it's all closed, and assuming that here we have 32 degrees Celsius, okay, theoretically, and outside we have 34 degrees Celsius, and the room is actually closed, and we know that we are not comfortable in 32 degrees Celsius. We have to be somewhere between 27 and 30 so that we are okay. So only temperature, how do we regulate the temperature? We are not turning on the AC, we are talking from the passive strategies. What we can do is we can increase the air movement in the room, okay, so that the heat that is there can be taken along with the air. Okay, what do? We increase ventilations in the space. Okay, so how do we do that? Okay, what kind of strategy is required to bring from 32 to 30 degrees Celsius. Okay, how much air exchange is required. Okay, all this kind of ideas we'll be able to draw using psychometric chart. Okay, not only in terms of air exchange, it will talk little more than that. We will see what are the parameters in which we can see that. Okay, now what is this model is all about? This model, the psychometric chart, is actually a model again, like I was explaining in the beginning. When we do climate studies, okay, there are two things that we should know. Okay, one is simplified model, where we just say, okay, you give an input A and B and you will get a result. Okay, we are satisfied with the result. We don't know what happens here before generating the result. What is this in between is the models. These are actually models available for processing this input A and B to generate a result C, okay, which we will use that in design. Psychometric chart is again is a model, and there are so many models available. I'll just show you some 3 or 4 models which can be used for arriving at a suitable strategies for a particular climate. Okay, one of the commonly used comfort model is, you can see here, it is already inbuilt here, Gioni's bioclimatic model. And in fact, I don't know this has been told or not, in all the textbook that we read, okay, is Gioni's bioclimatic model. It's one of the models developed by Gioni, and it has become a part and parcel of the psychometric chart itself. So if we click on the Gioni's bioclimatic chart, it tells you few information here. So it is based on the mean outdoor temperature. Here in this case it is 19 degree. Let us say we are discussing about Vijayawada or Chennai, where mean outdoor temperature is 32 is also fine. 30, let's skip. Okay, so it says this is in the entire period for 12 months, okay, or let's say in terms of the temperature, if you plot entire day, entire 365 days, if into the psychometric chart, we can say that only this part, okay, that you can see here is comfortable. Okay, in all other cases we need some kind of intervention to make ourselves comfortable. Okay, so let's see, I can export this. Okay, so it says, okay, if we are somewhere here, we are comfortable. Okay, in outside any days outside this zone requires some kind of intervention. Okay, what are those intervention? Okay, so for example, let's say if we are talking on higher temperatures, okay, this is the benchmark, we have 30 degree, we have kept it like this. And if the temperature increases further, okay, you have temperature horizontally, you can see here, this is 30, 35, 40 and so on and so forth. Okay, and we have also seen the relative humidity part. Okay, if the temperature is, let's say this is 35 degree, okay, and humidity is somewhere here in 50s or somewhere here in 90s or 80s. Okay, it gives you certain indication that you have to do this. we need air conditioning or dehumidification depending on the context to for to make ourselves comfortable. Okay, so for example, let us say if we are somewhere here, again let's say 32 degrees Celsius. Now we have an humidity of 60 degree and we are here somewhere. The suggestion is, if we improve the natural ventilation, we will be comfortable. Okay, so this is the zone. This is a zone in the psychometric chart for Vijayawada, where if we just improve ventilation, only this part, if we just improve ventilation, ventilation is air exchange, right? We don't have to define what is ventilation. So if we just improve natural ventilation, we will be comfortable. Okay. In some cases, let's say if we have 32 degrees Celsius, let's say for some reason we don't get to this level, but just theoretically for discussion, if our humidity level is very less, okay, we are very dry. So it says we should use evaporative cooling if we are in this zone. Okay, or if you have to use mask cooling, night ventilation, if we are somewhere in this. Let's say this is actually done as one of the strategy that you must have also read and commonly said also. Let's say if you are somewhere here 41 degrees Celsius and humidity is very low. Okay, what do? We say open up the windows so that night flushing. You must have come across this word, night flushing. Okay, so what I'm trying to say is the psychometric chart can be used to come out with this kind of passive strategies. Okay, so that we can translate this understanding into the design applications. Okay, so this is one model. I'll just show you the other models so that you also know what other models are and how it varies. So this is bioclimatic chart of Gioni. We have another chart which we normally use as ASHRAE 55 standard. In this, we have slightly little more information than what we had in the beginning. Okay, here we did not have control on the air movement or air velocity, right? We had only control on the outdoor temperature. Only using outdoor temperature, how do you say that which area will be comfortable and where we need some kind of intervention, so on and so forth. Let's say if we adapt slightly refined and higher models, like for example ASHRAE 55. ASHRAE 55, we have little more parameters for us to control on. For example, let's say it's no longer temperature. You can see here it was only mean outdoor temperature. It's dry bulb temperature. Okay, here in this case it's no longer outdoor temperature. It is going to be a mean radiant temperature. What is mean radiant temperature? I think you must have read it. If not, what you can understand is this is synonymously used with globe temperature also. Okay, so it says MRT, which is nothing but the temperature which we feel, okay, of air plus the radiative heat that we feel. Okay, so I think all the heat, okay, that we feel in a space, apart from the air temperature, is accounted in MRT. Okay, this is synonymously also used in globe temperature also. Okay, sometimes. Okay, so if you go here, we have MRT. Let's say we keep it to 30 degree. Okay, and it says what is the metabolic activity. You can see the terminologies also here. It says if we don't do anything, if we have if no activity, what is the metabolic heat? Okay, we are counting all these things in terms of heat. Okay, so what is this depth? And let's say if you are standing, what is the metabolic heat, the rate we have, and how does how that is taken into consideration? Okay, let's say we are doing some work, seated and relaxed, or maybe okay, some small activity we are trying to do. That's like we are writing this, that. Clothing level, it says different clothing levels. Let's say we are not in, I'm sure we are not in business suits in Chennai. Let's say shoes and pants. Air velocity, this is important. Now there's a major difference between Gionis model and the refined Ashray model. Now if you see in the Gionis model, what we said was if we increase natural ventilation, okay, we'll be able to achieve comfort level, right? So in the model, now it is integrated with the model, we can actually see how much air we can increase. Okay, let's say I'll keep it to, you have some notations for that also. Okay, pleasant and still, let's say I'm keeping it as 1. And by the way, I'll ask you one question, maybe you I'm not going to quiz you now. You find out how much air velocity that we get when we turn on the fan. We keep the fan at 5. Okay, so we keep the fan at 5. What is the air velocity that we get in terms of meter per second? Okay, just to get an understanding on what are these numbers. Okay, I'll just keep it as 1. And you can see just by increasing or decreasing the air velocity, the comfort zone varies. Okay, the comfort zone varies. So particularly in warm and humid climate, okay, where we need plenty of natural ventilation, for example in this case also, you can see that huge area is there where just by natural ventilation we'll be able to achieve comfort. Okay, that's one thing that we should understand if we read these data sets. Okay, so you can use, of course, more refined models and arrive at which area is comfortable. So in this case, this is the only portion where we'll be comfortable. When in all other cases we need some kind of passive and active interventions for us to be comfortable. There are other models also. You can will not go into that. There's ISO model and outdoor. If we are studying something on outdoor environment, and if you want to intervene something, for that also we can use this model. Otherwise, Gionis bioclimatic model is more than good enough for Gionis, and this Ashray 55 is more than good enough for us to proceed. This is European model, the third one, the last one that you see here. This is slightly improved version of the Ashray 55 model. Okay, and in case of India, we don't have this model as of now. In paper, we do have models. There's something called there is one model by, I'm forgetting the name, but it's not there as a tool which we can use. Otherwise, it's there. IMAX model. Okay, IMAX or IMAC, I think. IMAC thermal comfort model that is there on paper is yet to be validated. Okay, so this is one thing that you should explore on psychometric chart. This will give a lot of insight on what what we can do in terms of passive strategies, when do we apply passive strategies, so on and so forth. In fact, in climate, let's now check climate consultant in the same line. So that's why we can go there. Climate consultant gives little more option on what are the different strategies that you can use. Okay, so let's go there. I'm just, I have the screen is visible. I hope my screen is visible for everyone.
Yeah.
Yes,
Your
fine.
screen is visible.
Fine. Okay, thank you. So I'm going to do the same thing. Let's say I'm going to use weather file, which we have downloaded now. Okay, so I'm going to skip this because we have seen this in the how do we read the climate data. Okay, what are the different data and how do we do that? This is maybe this may be boring, this particular platform. Otherwise, the information is same. This is, you see here in numbers, we see that in graphics. Okay, so I'm just now adapting ASHRAE 55 model. I'll just leave this as it is. Let's go to, these are parameters. Okay, you can also explore this. I think you can read it on your own. This is on temperature, diurnal range, radiation, illumination, lux levels. We'll discuss about lux level sometime later. This probably will use this data for simulation, daylight simulation. Now let's only go and discuss psychometric chart. Okay, so it says here, if you plot, these are, each dot is the number of days. Okay, sorry, number of hours where we are comfortable and where we are not comfortable. Okay, it says 50% of the time, okay, is 4,000 hours is comfortable. Okay, whereas 50% of the time we required some kind of intervention. Okay, some kind of intervention is required for remaining 50% of the hours. What is this 8760 is 365 multiplied by 24. Okay, 24 hours and multiplied by the year. Okay, so if you go further, it says certain, okay, it gives you certain strategies. You adapt these things. Okay, so here it identifies 50% of the time we are comfortable, 50% of the time we need some intervention. What intervention? Based on the ASHRAE 55, it says you have to have a certain recommendation. For example, let's say good ventilation. Okay, to capture natural ventilation, what can be done? So these are some of the strategies that that is recommended to improve this number. At the moment, only 50% of the time is comfortable. How do we improve this number to 60%? It's not possible to achieve 100% for sure. How do we achieve comfort? Through passive means, let's say 60% of the time or 70% of the time. Okay, that's the intention, and it specifically gives you some idea on how do we do that as well. You can look, you can import the weather file and generate this psychometric chart, and you can check what are the kind of design guidelines that is mentioned here and see whether it is appropriate and it can be implemented or not. Yeah, this is Windows diagram. Let's not do that. Okay, so that's okay. So that's about the psychometric chart. Okay, we have only one small thing. We will just see this and then we can break after this. This is to continue with the next tool. It's called, let's say if we are interested in analyzing daylight, we should also know how daylights are modeled and how do we how does it work. Okay, what happens in the simulations, what happens in the modeling, behind the models, what is it and how things work. Actually, if we do models, if we do daylight simulations, what is daylight simulation? For example, let's say we have a room and we have given an opening, and it says let's say this is 40% opening, and in order to be comfortable, in order to be visually comfortable, what we need is we need a lux level of minimum of 150, right? I think these things you must have checked in the national building codes, right? So for example, let's say when you discuss your design, often we will say that this corridor is not lit, we need light here. When we say we need light here, how much light we need? Okay, for how much light we need, we should go back and check the standards, right? NBC says we need a minimum of 150 lux for corridors and public spaces. Okay, and for different activities, different numbers are given. 300 lux for regular work, or if you are doing some fine work, we need 400 plus lux level, or if you are in operation theaters, we need 600 plus lux levels. Okay, different standard table is given, which we can refer and see whether we are able to achieve that number or not. Okay, so what is the minimum lux level here required here, so that we can say that this window is actually satisfying the daylight requirement. Okay, in order to do this assessment, what we need to know is, first, what is the required level or the recommended level from NBC or any other guideline. Okay, for example, let's say if you are looking for LEED rating or Griha rating or IGBC, so on and so forth, they specify a number. Okay, for a room you should achieve so many lux level. Okay, so this is one. Second thing is, we should know the of course the percentage of openings. Number 3, we should know how this material finishes are done. Okay, what is the wall finish, what is the floor finish, okay, and how does it help in overall lighting level. Why? Light is actually composed of 3 things. When you say light, it's direct light, indirect light, and reflected light. Okay, direct light we all understand. Let's say this is sunlight. It's not whatever we see, whatever we feel is not the direct sunlight all the time, right? That's one part. The second part is the indirect light, or sometimes called as diffused light. So these are actually not direct light, these are diffused light. For example, in my room, if I see here, I don't have any direct light coming in. There is no sunlight coming in, but still I get light. These are diffused light. So theoretically, based on various studies, 15 to 30% of the lighting is achieved through diffused light. Okay, and there's a third component of light, it's called reflective light, where let's say it theoretically it constitutes to about 10 to 15% of the available light. So depending on the kind of wall finishes that we have, kind of floor finishes we have, this reflected light will vary. Okay, so we should know what is the material we use, okay, and what is the kind of finishes that we have. And the fourth component is, okay, all these things are at building level. What about the environment? Okay, it has to be simulated. How do we simulate sun? How do we know how much light is available in the outdoor environment? Okay, that also we need a model for that, right? That model is nothing but this CIE models, where where we have different, like we have seen for psychometric chart, there are different comfort models available. Like that, we have different models available for what is the outside lighting condition. What is the outside lighting condition? Outdoor lighting condition models. I can say outdoor lighting condition models. So sometimes it can be clear sky condition, sometimes it can be cloudy condition. Okay, all that is possible. So there are certain, I think 23 plus types of sky, theoretical sky available. Using that, we can model and check whether we are getting enough daylight or not in this particular room. Okay, so okay, to put it in a simple way, NBC says if we are in warm and humid climate, okay, it is assumed that 8000 lux level on an average, 8000 is the lux level for a clear sky condition. Okay, so when we do a simulation and then check whether we are getting enough daylight or not in this particular room, we are relating it to a number which is 8000 lux. For 8000 lux level outside, are we getting 300 lux level or not? Okay, that's the equation. So what is the equation? Let's say in a bedroom, or let's say in a study room, we need a lux level of 400. Okay, for what? For 1 lakh. Theoretically, sun, if we directly take the light meter and then measure the lux level, it will be 1 lakh plus. Are we comparing 1 lakh plus and then saying for 1 lakh plus are we getting 400 lux, or we have a standard number? The standard, actually we don't compare with 1 lakh lux level, the direct sunlight level. We actually have a standard model, the standard sky models. Okay, where in as far as NBC is concerned, we assume that if the outdoor lux level is 8000 lux. For 8000 lux level, are we getting 400 lux or 300 lux for other spaces, 150 lux for corridors, or 600 plus lux for reading rooms, so on and so forth. So this is the equation. So again here, what are we trying to do is, we are trying to model environment in a smaller scale to understand whether our building will work in that in a realistic condition or not. Okay, so let's quickly check the model. You can see here, I'll just go here. It says there are here you can see some 16 sky models. Okay, so let me go to the same. This is Vijayawada. Okay, and I'm not going to details of all this, just to give an idea that when we say daylight simulation, or when we say how do you evaluate the building for daylight, we need to know some basics. This is the basic. We assume certain sky condition. For that assumed sky condition, our building will work or not is the question. Okay, if you want to know more about how do we model this sky conditions, all that's another topic. In fact, a lot of research is done on this level by architects especially. Okay, so let's say it's something called overcast sky condition, clear sky condition. Generally, what we do is here in the studios, we recommend that the building should be tested for overcast sky condition. Overcast sky condition, there are three basically, you can say. One is clear sky condition where there is no or almost zero, you can't say zero, let's say less than 10% cloud cover. If the sky is less than 10% cloud cover, we say it's a clear sky condition where there is no the obstruction of there is no obstruction for sunlight. Okay, that's one thing. Here, I think in all most of our building will work, right? Because it is a clear sky condition, and in average we will definitely have 8,000 lux level in the outdoor condition. More than that, in fact, definitely more than 8,000 lux level, and we'll be able to achieve the 300, 400, 500 lux level that we are intending for. However, in case of overcast sky condition, let's say we don't get to see sun at all. Okay, it's all it's all cloudy, and it's all blocked by thick clouds. Okay, sun is there, it's all blocked by cloud, and still we get light, right? We do have light. This condition is called overcast sky condition. Normally what we do is, if we satisfy our building for overcast sky condition, in all other condition by default it should satisfy, because this is going to be extreme condition. Okay, so we have something called overcast sky model, and we have something called clear sky model that you can check here. That, and of course this again depends on different latitude and longitude, how much sky is available, and how much lux levels are available, and what we can do. Okay, this is one thing. The second thing which I thought I should discuss is on the shading mass. Okay, now we will discuss. We'll also do one small analysis on daylight later. Before, it's about bringing daylight. Okay, so maybe in most of the cases like Chennai, Vijayawada and all, we don't want sun. Okay, that's another thing. How do we block sun? That's another question, right? We want light, but we don't want sunlight, direct sunlight. We are okay with diffused light, all that is fine, but we don't want direct sun. How do we know that how much sun is available, how much sun we get in a given point of time? Let's say if you have an opening of X meter by, let's say if this is your layout, and you have a opening here, and I want to know how much sunlight I will get directly here, till which time I will get light here, so that I can do the shading element appropriately. Okay, so for that, what we need to do is we need to have an understanding on something called shading mass. Okay, that's what we are trying to look here. Let's go to the model. I'll just reopen it here just for everyone to understand. Okay, maybe there are too many things to say, so I'm just holding myself. Okay, let's open this. There's a tool called dynamic overshadowing. If you open this, it has got again a sun path, okay, and some models that you can see here. What we can do is, let's see if we can no, we can't import weather file. Okay, we can't import weather file, so we just have to give location. Okay, so what we'll do is we'll just see set location. Okay, so this is Vijayawada, and the sun path on a dome or let's say this is how it is looking. Maybe let's see if we can increase. Okay, so now we have a sun path. Okay, and we have also we have some let's say blockage, let's say kind of a building around. It tells us this is the sun path, and we know that the sun will be available during this time. Whatever you see in yellow part is where we will have sun. Okay, so I'll keep it in plan. That's the correct way of looking at the diagram. Okay, now we have this, and you can see that if you have buildings, okay, it is creating some kind of a shading here, so which is nothing but it is shading the sun path. Okay, direct sun path. So let's say if you increase block, okay, we are able to say that okay, it is blocking the sun, not overlapping, let's say it's blocking the sun. Okay, so what is that we need to take from here? Let's say let's make a model. Let this be, let's make this as an okay. So let's say we are trying to analyze a layout. Which area requires okay shading? How much of the building, how much of the sun path is getting blocked, okay, for specific layout? Okay, so this is one of the easiest tool for understanding this particular subject. Okay, so let's say we have 4 walls, but still most of the area is unblocked, unshaded, not unblocked, unshaded. These are the black one, the color that you see is the area where we are able to shade the sun. Okay, and this area does not, of course it is open here, that's why we are not able to block it. Let's say we block it. Okay, you can do any model, you can have you can bring in, or you can try to understand how the geometry will block the sun, or even after doing all the blocks, whether we are able to block the entire sun or not, all that can be verified. In fact, in this case you can bring in your own model that you have made. I think we made one model. I can okay, so we have a model and it says how much of the area is blocked or unblocked, all that can be seen. I'll just see if we can, yeah. We can have control on the building because it is kind of yeah, this is okay. Yeah. Okay, just for our model is there. Okay, theoretically model is there. How much of the building, how much of the entire sun path is covered or not covered, where we need shading, all can be tested here. Okay, so ideally this is not the best tool for generating this shading mask. There are more simpler way of generating shading mask, but I recommend this because all other tool does not have this flexibility of going around and checking the models. Okay, that you can do here. Okay, so I think I don't know how much I have done. Let's see. Yeah, that's all I have to say. There are certain things. Daylight we can do. Probably I'll introduce you how to do daylight modeling, and there are a lot of work that is being done on tools available. Sorry, one second. Yeah, so there are different tools are available. Okay, I have put a reference here. You can check this reference. There are more than lot of tools, free tools are available that you can explore. What I know is only one or two simple tools that I use, and that's what I'm trying to explain here. And there are different tools. For example, let's say from the same paper I have taken name of the tool, where you can look for and where it is applicable, whether it is commercial or not commercial, all that you can check, and where you can use, whether you can use this for commercial buildings, or because see, residential buildings require different models, right? The material usage, the activity, the opening schedule, window percentage, all that is different from commercial settings, right? So some of the tools are made only for commercials, some of the tools are made only for residentials, and so on and so forth, that you can check in this paper. This is a recent one. So the recent one you can check that, and this is one tool which I thought I'll introduce you. Maybe if you have time, you can. This is also a simple tool. Like I said, I have put here. There's something called white box or the black box. Black box is we don't get to know what happens inside the model. Okay, so we have a building, we give an input data, and we get a result. Okay, so what is the model adapted? If we modify the model, can we have control on the parameters of the model? All that is not. Some of the tools does not have, some of the tools do have. My observation is we don't need, all architects does not need for day-to-day work. We don't need the model. Nobody is interested to check and refine the models unless in the academics we want to refine that model further and so on and so forth. Otherwise, architects are not interested in doing that. What we need is we need the results and that are scientific in nature. Okay, so there are tools available for that. You can look for it. More informations, you can read that. And this is one tool. Let's see if we have time, we'll do it later in the afternoon. Yeah, and apart from this tool, I think those who are using Revit, they should also be knowing this tool called Format. where you can do basic, like all the analysis that was possible in the Ecotec is now possible in format. Okay, it's taken over by that. And for daylight also, we will see one tool. I told you two things. If we have time, we will see. This is whole building simulation, and we will see one daylight analysis. How do we do model? How do we model it quickly, and how do we generate results, and how do we read the results? More important, we'll try to do that. And otherwise, there are tools like VLEX. These are free softwares for daylight simulation, where it will be able to tell how much lux is available for a given model and sky condition. And there is a tool called 2D and Energy 2D and Energy 3D. This also I use for only for explaining things and explaining the physics aspects, building physics aspects primarily. For example, we have a lot of issues in understanding on how conduction takes place, how convection takes place, what are radiation, and how does these things implied for buildings. Okay, so there is a tool called Energy 2D where these concepts can be understood in a very simple manner, the way I showed for climate data and psychometric chart and so on and so forth. Okay, and there are more professional tools are available for whole building simulation, design builders, Ecotec, and so on and so forth. Those things are not we are trying to. Okay, so this is all about buildings. What, like I said in the morning, we can do a similar understanding. We can have a similar understanding for an urban scale also. Same thing happens at urban scale, but in a larger manner. Okay, maybe in the afternoon I'll quickly introduce you to some ideas that we should have on urban scale when we talk about climate and build form, so on and so forth. What kind of terminologies that are commonly used, like we use in building level. Okay, that's it for this session. So I say that we should have some scientific temperament for design. Okay, so unless we have this attitude of looking at things in a scientific manner, this may be boring and maybe not relevant. For many it may say it's not relevant. How is it relevant? We already know this. For that attitude, this is not a correct platform. I think we should have a more scientific temperament for whatever we do. Okay, so we need to have architects. As an architect, what we do, we say that okay, it will work, it will not work. Okay, it will work is a subjective word, and which many times it may not be accepted. Now we need numbers. We need to quantify things and show yes, it works. This is how it works. Okay, so for that we have to have scientific temperament, and we should know certain basic tools. We need not be master of this XYZ softwares. Maybe if you do it, it's good. Otherwise, we have simple tools which we can use it on day-to-day basis to make scientific judgments. Okay, and in addition to that, one other thing, maybe since we are discussing in the academic platform, we can also do this club this simulation with the field measurements. Okay, so I ask you a question on can you tell me what is the wind or air speed that you feel if you keep a fan in 5 point, and if you measure it, what will be the air speed? If I ask you the number maybe will vary from 5 to 15, maybe 20 also. Okay, so that is not the case actually. If you have an instrument, kindly take it and bring it and check what is the wind speed or the air speed that we are talking, even if you keep your fan at 5. Okay, so that we know what are we talking. Okay, that's one thing. And also, like I said, simulation is fine. We should not only get carried away by all these tools. we need some physical data to validate whether our simulation results are correct or not. Okay, so for validation, because all the models have errors, okay, all are bound to have errors. To minimize the error, we need to do some physical experiments, physical data collection also, so that our simulation results are more acceptable. Okay, and last thing, we should read a lot, because there are, for any subject you take, particularly in building simulation and building research, every day I think there are 100 papers are published, more than 100 papers maybe. Every day is too short. Maybe let's say every month we have hundreds of paper published on this particular topic. So that means thousands and thousands of people are working on this area. If we are interested in specific aspect of it, I think we should look for right papers, right platforms, right institutions, right researchers who are working on this particular platform, so that we have a good understanding on what are we talking about. Okay, last slide. My suggestion is, what you can do is you can do this exercise. We have discussed so many things. I would request each one of you to check this. Try to plot a 2D sun path for your house. Okay, specific house. Okay, just take out from, you can zoom in. I think I showed you. You can go into the maps, identify exactly where is your house located, and see whether you are able to plot your building on the sun path. Okay, one. Second thing, you take a block model of your house. Okay, import it to the 3D sun path and see how it works. Okay, what happens, and you know it better. How's your house located? Where are the openings? And how your house is exposed to the sun. Okay, from January to December, from day night, what happens to the model. Okay, just check that. Then you develop a psychometric chart. I told you how to do that for a specific location, maybe for your own city location, and see what kind of outputs that you are able to generate. Okay, and I also told you how do you block the sun. Okay, so you already have a model in hand. You can create another model with just one puncher. Just put one opening, realistic opening. Since it's going to be your own house, you know where are the windows. Just put a window there, one window. Just do it with one window, and you already have a 3D model. Just check whether you are able to generate a shading mask for that particular room. Okay, which part of the year is getting blocked. Okay, which part of the sun path is able to you are able to shade using the sunshade that you have. Okay, just take it and then see what can be done. Okay, and last thing, daylight analysis. I have not told you. Maybe if we see it in the afternoon, you can do this as well. Maybe I'll introduce you. It will not take more than 20-30 minutes. We'll do that. Okay, I think I'm done for the session. If you have any questions, you can ask me. Otherwise, we can take a break here.